Okay, sir. It's okay now. You can start.
Okay. Um, so the flight laboratory, which is part of the Department of Aerospace Engineering in IIT Kanpur, is a very unique facility. We basically have three aircraft, one Piper Saratoga, one Hansa, which is an indigenous aircraft designed and built by National Aerospace Laboratories in Bangalore. And we also have a Cessna 206 and a glider, a powered glider. So the idea of having this aircraft is that we want to give practical instructions. We basically want to teach the practical aspects of flight testing, doing experiments in flight. We do experiments in the lab. We have wind tunnels where you can do a specific controlled kind of experiments. Whereas these are experiments which you do in real time. You actually fly the aircraft. You determine whether whatever your design parameters are in terms of the drag or lift or the climb performance. So there are so many parameters with which you design the aircraft. So these are experiments which help you to validate those design procedures. And what we do is we have close to 300 students who come every year, and we have a 10-day module course wherein we have the students conduct some of the experiments in flight. They fly in the aircraft, take the data which they can. Some of the aircraft are instrumented, some of them have their own instruments which came with the aircraft. So we teach the students how to use this data and basically calculate the parameters and the performance that they need to check. So that's from a teaching point of view. And in terms of research, so as you can imagine, some of this can be extended also to research in terms of estimating, so what we call as parameter estimation techniques. So that based on the flight behavior, it's how quickly it's turning, how quickly it's rolling, and so on. So you can determine certain aerodynamic parameters, dynamic parameters of the aircraft, and so some of that research activity is being done with the aircraft that we have in the flight lab. I personally work in the area of structural health monitoring. So what the idea is to have some kind of, these days you have these Fitbits, wearables, and you have pedometers where you can measure how many steps that one person is walking. So the idea is to have the same kind of philosophy for aircraft. So our idea is to embed or have sensors in the aircraft so that we are able to measure how long has it flown, what kind of aerodynamic forces it has seen, did it go through a gust, did it go through a storm, did it have a hard landing. So the idea is to be able to record all this data and basically give an assessment of how, what is the integrity of the structure, meaning, is the structure, does it need repair, does it need to be maintained, and more importantly, one of the key aspects of this technology is you can decide that how much life has been exhausted. So it's like saying that I have walked 100 10,000 steps today, and I think you need to take some rest, or I don't think you should walk. So the idea is to assess what is the current life of the aircraft and how much of life is remaining. And where is this useful? It's basically useful, especially in case of say Air Force. So they have aircraft which are very expensive, which are very difficult to maintain. So if we have this kind of a system, say in a fighter aircraft, it is possible for us to say at any given point of time how much life of the aircraft has been utilized and how much of life is remaining. And this helps them to take a very rational and data-driven decision as to whether that aircraft needs to be retired or it still has life remaining that it can be. So it has a lot of strategic advantages and it has a lot of economic benefits. And that we are hoping to achieve by having fiber optic based sensors in the aircraft, and see how we can use this data, how we will process the data, on what basis do we say how much life is remaining. So it involves knowledge of structural mechanics, it involves knowledge of material behavior, it involves knowledge of understanding how loads act on it. So this is the kind of thing that we do in the flight lab. And the flight lab, I should say, is it's actually it is certified by the Director General of Civil Aviation, so it's an authorized maintenance facility. We have a very able team of maintenance engineers who are also approved and certified by the DGCA, and that team is led by Mr. Vipul Mathur, who is the Chief Engineer of the Flight Lab, and he's also approved by the DGCA. So it's a very formal organization structure, it's a very formal facility, but it's extremely unique. As you can see, our idea is also to inspire over these 300 or 400 students who come every year. Some of them haven't even flown in an aircraft earlier, so it gives them an idea of what real practical value of aerospace engineering is, and I hope it motivates them and inspires them to research or get into teaching and basically spread this wonderful area of aerospace engineering.